welcome to this third tutorial on Autodesk Fusion 360. Starting from this video and onwards, all tutorials will be based around practical examples such as wing ribs, the Laval nozzles or rocket nozzles, implementing 3D printing, and such. In this tutorial, you will learn how to create a parametric model, this using two methods. The first one that we will tackle will be using the Revolve function, and the second method will be based around extrusions. Next to that, you'll learn how to add a material to your models. Okay, so before we get started, the part that we will be creating today is a flange from the Renard R37, 38 and 40 series. So let's show the part that we will create. As you can see, this is a copy of the original design plans provided by Renard. The part number that we will design in this video is 30.900. As you can see, this is the flange that we will be designing today. Okay, so let's open the sketch panel in our Fusion 360. So either click Create Sketch or just simply press L. In this case, let's select the X and Y plane. Okay, next just sketch a rough shape that resembles half of the cross-section of the flange. So just to show the flange again, this is the flange and we will be creating a cross-section of this. So let's see if I can draw on this. So what we will be creating is if we have a flange, we will create this part for the revolve function. Okay, so let's just create a rough sketch of it. Just like this. And yeah, if done correctly, you should have this kind of L shape. But as you can see, it's still all in blue. So what we want to do is constrain the model first. So in order to constrain it, let's make sure that the bottom side of the flange is aligned with the x-axis. Let's toggle on our origin. So you can just press the I, and that will make your origin visible. And let's now make sure to align it. Let's align this with the x-axis. As you can see now, the bottom of our flange is constrained. Now that we've done that, let's add the dimensions. Note that because we want to use parameters, we'll first define a letter and then assign a numeric value to this letter, also better known as a parameter. For the inner and outer diameter, namely being this the inner diameter, this being the outer diameter, and we will define this as the thickness. For these, we will define a parameter beforehand, as they will be used to calculate the radius. So let's go to the Modify tab, change parameters, and now let's add a new user parameter. Let's enter a name. Let's just choose DO, and let's say the outer diameter is 72 millimeters. Okay. Next, let's add another one with the inner diameter. The inner diameter has dimension of 50 millimeters. Next to that, let's add the thickness of the wall for the flange. So let's just give it the name T. And this has a thickness of 3 millimeters. Okay. So now select the sketch dimension and place your dimensions. So in this case, we will say that it is equal to di divided by 2. Let's call it RI. Okay, now we have the inner radius, and for this we will just type T, as this is the parameter that we'll be using. Okay, then for the outer diameter we'll do the same. We'll be using a radius, so the outer radius equals the outer diameter divided by 2, just like that. And as for the height, let's use two heights. Oh, yeah, in case you accidentally change your view, you can just use your viewing cube to fix it again. Okay, so now we've got our view back. So let's define our first height, h1 equals 3 millimeters. And our second height is 12 millimeters. h2 equals 12. Okay, so now we've got the basic cross-section of our flange. What we can do now is just click the Finish Sketch button, then go to the Revolve function, select the area, and in this case it automatically selects the area that we want to use for the revolution function. And now just select your axis. In most cases you can just select the y-axis, but then make sure that your origin is visible. So let's select this, and now it will create a full 360-degree round revolution. And press OK. Now that we have created the revolve, let's select the bottom part of the flange and start creating. So let's just quit this. Yes. So what we will do now is we will create the holes and these radiuses. So this is the next thing that we will create. Okay, so let's select the bottom part of the flange and create a new sketch. Just like that. And just in order so that we can see where just in order so that we can see the blinds or the wall thickness with the thickness of 3 millimeters, where that ends, so that we make sure that our hole doesn't intersect the wall. We can go quickly to like 3D view, just like that. Then go to project or include. Just click the project button and choose this side. This way we can visualize the perimeter of the thickness of the flange, just like that. Okay, let's go back to the bottom view. Let's lock our view so that we can go in 3D mode again. Okay, and now let's add the holes. So in total there are 8 holes with a diameter of 4.5 millimeters. So how we will do it, we can just create one hole. In this case, let's just like that. Unconstrained, let's add a parameter like dh from diameter of the hole equals 4.5 millimeters. Okay. Next thing that we will do is make sure that it coincides with the z-axis, just like this. And now we'll define the distance from the center. So let's say we always want it to be in the middle of the outer diameter and the defined thickness of the wall. So if we have a thickness of 4, it will automatically correct the hole so that it's always in the middle of the actual flange that we have. So if you would look at the part upside down, like the overhang that you have, you always want the hole to be in the middle of that. Okay, so in order to do that, let's just take the outer radius, namely 72 divided by 2, so 36 millimeters, minus our inner diameter divided by 2, or our inner radius, and this minus 3. Or to put it, just put it otherwise. Okay, so now we can define the distance from the center. So we can just simply define that by, so let's select it. Okay. Like, let's call this one A. A equals, let's use brackets, our outer radius minus our outer radius minus our inner radius minus our thickness, and this divided by 2. Let's see. There seems to be an error. I'm not sure what it is. Maybe it's just a small thing. Okay, so in some cases, like some letters you cannot use. Yeah, it could be related to like area or surface area. So in most cases, make sure that you, like, if you have a red formula, make sure to check if the letter you're using isn't already used for Autodesk Fusion 360 itself. Such as, just to give a simple example, if you will use the big letter T, it will not use it because it is used for temperature calculations when you do simulations. So let's just choose H3 again. Ah, my bad. Made a small mistake. Let's change it around. It's not like this, but it's like this. Yes. Okay, so now we fixed that. Let's create a circular pattern. But we can choose how we want to do it. So there are 2 ways that you could do this. You could first of all create a circular pattern and then cut them through the flange, or you can just create one, cut it through the flange, and then create your circular pattern. In this case, I'll choose the latter. So first of all, I will extrude it and then create the circular pattern. So the next thing that we will create is the other holes that we have, these radiuses, and these have a radius of 5.5 if I'm correct. Yeah, 5.5 millimeters. So in order to do that, let's first give them the correct angle. They have an angle of 45 degrees. So for that, let's create a line. Let's give it the same distance. So let's create a line just like this. And make sure that it goes all the way to the perimeter of our outer diameter. And let's give it an angle of 45 degrees. So let's say alpha equals 45. Oh, my bad. 45 divided by 2. Alpha equals 45 divided by 2. Okay, just like that. Let's now create this section. And it has a diameter of, let's say, D. Let's call it dx in this case equals 11. Just like that. Okay, now we've done that, we can just finish the sketch. Press extrude. So let's go to the extrusion. Select the profiles that we want to extrude. And we can just cut it all the way through. Just like that. Okay, press OK. Now that we have that, we can select them using the Control key or just selecting our extrusion in our timeline. So let's select the extrusion, create, go to pattern, circular pattern. So yes, there are objects and features that we want to select. Like you could also do it for bodies, but in this case we're talking about a feature, such as an extrusion. Next, let's select the axis around which we want the pattern to be fulfilled. Okay, so we've chosen the center axis, and now 8. And if we now press enter, we have the basic shape of the flange. Of course, we still have a radius of 3. In order to do that, let's go to the fillet and select all these edges. Okay, and once we've selected them all, we can fill in the value. In this case, 3 millimeters. Yep, so we have selected all the edges, 3 millimeters. Hit OK, and here we have it. Now, as you can see, we still need to add these holes. These holes have a diameter of 3 millimeters, if I'm correct. So for that, let's just choose a plane, just like that. Create our circle, and say dy in this case equals 3 millimeters. Okay, here we go. Now let's make sure that it's aligned with the center axis. Okay, and the total height of this should be h2 divided by 2. So let's select this as our reference point. No, chosen the wrong thing. Dimension, just like that. Let's take h4 equals h2 divided by 2. Just like that. Finish sketch. Extrude it. And now again create circular pattern. In this case we won't choose faces, but again we will choose the features. Select the last feature that we've used, namely the extrusion or the cut that we made. Select the axis, and again 8 holes. Yeah, I've just realized we've made a small mistake, or I've made a small mistake. This has to be inclined under a certain angle, so the hole has to be between the main holes for mounting the flange, which actually isn't such a bad thing, because now I can show you something else, namely how to create a custom plane at an angle. Okay, so let's return. Let's create a plane at an angle. Select this axis and 45 degrees divided by 2, just like that. Okay, and now we will just do the same. So dy equals 3 millimeters. Align it with the y-axis, and again define the distance above the upper side of the flange. In this case, h4 equals h2 divided by 2, just like that. Now we will extrude it, just like that, and create a circular pattern. Okay, let's not go for the faces, but for the features. Select our feature, and then our axis, and indeed we have 8 holes that need to be made. So now we have our flange. Now we have created the flange of the Renault R37, 38 and 40 series. But of course now we don't have a material that is defined to it. So in order to do that, you can go to bodies, select your first body, and then physical material. Now your Fusion 360 will bring up the physical material panel, and here you can choose what material you want it to be. In this case, let's just pick the aluminum 6061 hot formed, just like that. And now the physical material has been assigned to it. Just to check it, you can go to properties, and it will tell you the density it has. You can also find moment, mass, etc. As you can see, the physical material is set to aluminum 6061 T6 hot form. Okay, but now we have created a parametric model, but why is it useful? Well, it is pretty useful because you can just go to your Modify tab, then change parameters, and here you can change all the dimensions. So let's say I want the thickness to be, where is it? User parameters. The thickness to be 2 millimeters. And now it has changed the thickness of it to 2 millimeters, just to make sure that it's correct. As you can see, now the distance between the inner surface and the outer surface is 2 millimeters. So this is pretty useful, especially if you have like iterative design, or you want to look at what effect certain dimensions have on your design. Parametric modeling is really useful. It's a really powerful tool. And especially for complex parts, I advise you to use it. Yeah, like for simple parts that are just straight on, you know that those are the dimensions that you will be needing, you can do that. But if you have more of a iterative design, it's not a bad idea to use parametric modeling. Okay, so now let's try to do the same, but starting with an extrusion. Just like that. Let's go all the way back. create our sketch, but now let's select the X and Z plane. Okay. Again, you will be using the diameters that we used before. Yeah, practically it's just the same that you will do. You'll use the same parameters, but now you will use extrusions. And actually, maybe it's not such a bad idea to give it as an exercise to try it yourself. It wouldn't be a bad idea to try make it yourself and create the model. After having created the flange with part number 30.900 using the Revolve function, let's do the same making use of extrusions. First of all, let's create a sketch. In this case, we'll be using the XZ plane. So once you've chosen your XZ plane, create a circle with an outer diameter DO of 72 millimeters. Next, let's constrain it. So let's constrain it to the origin. And now let's draw the inner circle with diameter DI equals 50 millimeters. Next step is to define the thickness. So for doing that, let's go to parameters. This is something that you can find in the Modify tab. Change parameters, user parameters, create a new one. Let's call it small t and give it a value of 3 millimeters. Okay. In order to define the outer diameter of the wall, we can use a simple formula. First of all, let's make these two concentric, just like that. And now, let's just say that this equals d, our inner diameter, plus 2 times our thickness. Equals our inner diameter plus 2 times t. Just like that. Now let's draw the indentations and the holes that are situated in the flange's base plate. For that, let's create a circle with diameter dx equals 11. Let's constrain it just like we did last time with the Revolve situation. So let's visualize the origin. Okay, and make sure just like that. Next, let's create the hole. Give the hole diameter dy of 4.5 millimeters. As we did last time. And say A equals, using a small formula for finding the center of the outer diameter of the flange's base to the outer diameter of the wall thickness. We can just simply find that by saying that this is our outer diameter divided by 2 minus our outer diameter divided by 2 minus our inner diameter divided by 2 minus our thickness, and this divided by 2. And we can call this A. Okay, next let's give it the same angle as we did before. Give it the same angle of 22.4 degrees. Or just 180 minus 45 divided by 2. Okay. Now constrain this to that. So I just see that we should better change this up. Minus dw. Okay, just like that. Just a small mistake that got into it. And we've got our alpha. And the next step is to create our circular pattern. Circular pattern. Check everything we need. Select the center axis. And in this case, we didn't select everything. Like sometimes you can have it that you will select the center point of the circle, but in most cases you want the perimeter of it. Center point, and we want 8 instances. Just like that. Okay, let's now finish our sketch and start with extruding. So let's extrude it. Press the E key or just go to extrude. And here let's say this is h1 equals 3. Okay, now our sketch disappeared, but we can just simply fix that by going to our sketches and clicking on the I button to make it visible again. And now let's extrude our wall that we have here. Let's call this h2 equals, in this case let's go for 15. Okay, let's hide our sketches again, just like that. And now create another sketch for our holes that we need to make in the wall. So here let's choose dz equals 3 millimeters. let's align it with our y-axis. Okay. And the distance it needs to have, as seen from the top of the flange's base, equals h2 minus h1, still need to place brackets, divided by 2. Okay, and now it's in the middle of the extruding of the extruded section. Okay, so if you will change your base plate's height, it will also change the distance that the hole has, as seen from the top of the flange. So yeah. So much. Extrude it. Okay. Now let's create our circular pattern. Go to patterns, circular pattern, select the features button, like the hole that we made. Now the axis, you can choose inner face, outer face, or just one of the perimeters. In this case we'll go for the inner face and select 8. Press OK. Now let's create the fillets. You can just go to fillet or press the F button. And let's create all our fillets that we need. So selecting all the sides that we want to add a fillet to, just like that. Okay, and give it a size of 3 millimeters. Hit the OK button, and now let's go to bodies, right click it, physical material, metal, and go to the aluminum 6061 hot form. Okay, close. So now we have created the same flange as we did before, but using a different technique, and it's still parametric. So in order to show you, let's go to change parameters. Let's maybe make it a little bit smaller so that you can see what happens. And let's just say that we change the parameter to 1.5 millimeters. You can see the holes changed position, the wall thickness decreased, and yeah, everything else just adjusted itself. So let's reset it, modify, change parameters. In this case, let's change our height to, let's go a bit extreme, 30 millimeters. Okay, as you can see, the holes are again in the middle of the wall section. Let's reset it to value of before, 15. We have our hole sizes, 50, like we can decrease the inner diameter. Let's go for 30 millimeters. Okay, as you can see, it just changes the sketch. Okay. So that was it for today's lesson. In the next lesson we will be looking at how you can create wing ribs using the sheet metal function. So yeah, until next video, I hope you enjoyed, and I wish you a lot of success during the workshop. Okay, goodbye, and hopefully till next time.
See ya.